All right, so let's start this unit by talking about exponential growth and decay. So there's two formulas you are doing on this. So this is used for like real life situations, interest rates that you will use for cars and credit cards. If you go into the science field, you could do a lot of stuff with exponential decay and growth. There's just a lot of different applications that you can do this, but everybody will use this at one point in their life, whether it be for a house loan, a car loan, some bank account, you will use this. Okay, so here are the two different formulas that you need to know. So the first one is the one that's used most often, and this is how to find the interest rate of something that is compounded during a certain amount of time. So when you're doing this, the P is your principal. Okay, so that's your initial amount, how much you're putting into it. The R is your rate as a decimal. You're going to have to do some converting between decimals and percent. N is the number of times it's compounded in the time, so we'll talk about that. You're gonna have some different ones. And then T is the amount of time. Okay, this is the formula that is used most often. There is another formula that is called, I call it the PERT formula because it looks like PERT. So this is only whenever something is compounded continuously. Okay, if you do not see the word compounded continuously or continuously, you do not use the formula, you go to the other one. So that is the key word. Whenever you're doing this, the P is still your principal or the initial amount. The E is actually a number. It is like 2.7. It's an irrational number, kind of like pi, and there's a certain button on your calculator to hit to log that number. R is still your rate, and then T is still your time. Okay, so let's do this. First, the number inside the parentheses tells you whether it is growth or decay. So if the number is between 0 and 1, then the function is exponential decay. And if the number is greater than 1, it is growth. Okay, so let's talk about, they want us to arrange these in order from fastest to decay to fastest growth. So let's just talk about this one. So how you know if it's growth or decay, you don't even care about the number out front. You are just looking at the number inside the parentheses or the number that's being raised to the power. So if it's greater than 1, it's growth. If it's in between 0 and 1, it's decay. This must be growth. Okay, so because it's 1.8. Now let's talk about how much it's growing, because you're going to need to know this, the rate that it's growing. Whenever it's growth, how you figure out how much it's growing is you take the number and you minus 1. So this would be 0.8. How much more than 1 is it growing? Well, it's 0.8. And now usually they write growth or decay as a percentage. That's the common thing to do. So what is 0.8 as a percent? You move the decimal over twice, and that would be 80%. Okay, this next one is, you're looking at the number in the parentheses. It's greater than 1, so this is going to be growth. And then so whenever you're finding growth, to find out how much it's growing, you take that number and minus 1, and you get 5. So how much is that growing as a percentage? Move the decimal place over twice. That would be 500%. And some of you may be like, well, why is it not growing 600%? Is because you do not take that, why we did minus 1 is you don't take that first 100%. That's the initial amount. It starts at that. So it's then getting bigger from them, and it gets 500% bigger. Okay, this is a little different. There are no parentheses, I realize. So if you would like, you could write it like that so you could see what the number is being raised to the power. So sometimes there might be parentheses, sometimes there might not. If there is no number out front like the other ones, know that number is 1. So what is this, growth or decay? Well, that number that's being raised to that power is less than 1, so this is going to be decay. And how you find the percentage on this one is a little bit different. So on the other ones we did the number minus 1. For decay, you're going to do 1 minus the number, which gives you 0.5. You still need to move the decimal place over twice, so this would be a 50% decay. The next one, what would this be? It would be a decay. We need to do 1 minus 0.75, which gives you 0.25. So this would be a 25% decay. And then there's one more. This would be growth, right? And so we're going to go back. So 2.5 minus 1 would be 1.5. So this is 150% growth. All right, so the fastest decay, it looks like it was A of t, because that was decaying at 50%, and that's faster than if it decays at 25%. The next fastest decay was the only other decay, so that would be G of m. Okay, now we're on to the growths. So we're trying to do the slowest growing one first because we're trying to end with the fastest growing. The slowest growing one looks like your Y. That one is only growing 80%. Next would be the W of K, because that's growing at 150%. And finally, the fastest one is your F of X, because it's growing at 500%. Cool, so that's how you tell the difference between growth and decay and find the rates. You will need to know this stuff so you can be able to know how to graph them, what's happening. There's a lot of stuff you can do with this. Okay, now let's actually solve the problems. So suppose you invest $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will there be in the account after 6 years? So let's start. Are we using the PERT or the first formula? And the answer is the first formula, because there is not the word continuously at all in this problem, so you do not use the PERT formula. So we've got our P is our initial amount, the principal, which is 1,000. We also need the R, the N, and the T. So the R is 5%. Now this is where it gets a lot of people mess this up. How do you write 5% as a decimal? Well, you got to move the decimal over 2 times, and since you're going from percent to a decimal, you need to move it 2 times to the left, and that gives you 0.05. Okay, the time, it says after 6 years, so that would be 6, and the N. The N on this, usually, unless they tell you that something is compounded quarterly or monthly or weekly, usually your N is 1, and on this case it is because it's only compounded once a year. Okay, so usually it is 1. All right, so now we've got enough information, let's plug it in. So we've got our formula, so P parentheses 1 plus R over N to the N times T. So 1,000 parentheses 1 plus 0.05 over 1 to the 1 times 6. So whenever you're typing this in your calculator, anytime you have an exponent that has 2 things happening, you're probably going to need to put parentheses around that when you type it in. So just to give you a heads up on that. Okay, so just to let you know, another way you may see this written even on the homework today is you may see it as 1,000 parentheses, and then they combine that stuff inside the parentheses. So that would be 1.05. Right? Look at it, 1 plus 0.05 over 1. So it'll be 1.05 to the 6th power. Know that those are both the same exact thing. You can solve it either way. You can type all that stuff in, or you could just do the second one. It's a little bit faster. So that would give us, whenever you plug that in your calculator, it would be 1,340 points. And now this is where people mess up. We're talking about money here. So in our society, we always round money to 2 decimal places, so 0.10. All right, so that would be your answer. All right, so let's do a few more. So suppose the city of Bellevue is decreasing in population each year by 0.8%. If the current population is 60,000, predict what the population will be in 2040. So start with what we know. The P, the initial amount is 60,000. okay? The rate is 0.8%. People mess this up. So 0.8, I need to move my decimal place over twice. So this is 0.08. The time, okay, this is tricky. If it's year 2018 and we're wanting to know what it'll be in 2040, you need to subtract them. 2040 minus 2018, that would be 22 years. And then the n on this one is 1 because it doesn't say anything about compounded yearly or daily or anything like that. Okay, so plug it in your formula. You've got 60,000 parentheses 1 plus, I'm gonna skip the r over n part for this one because the n is 1. If you would like to write it, you can, but I'm not going to. So 0.008 parentheses to the, again, I'm not gonna do 1 times 22, I'm just gonna write 22. If you wanna write it, it doesn't matter, but I'm not going to. Oh, I just see I made a mistake. What was the big word that I circled? Decreasing. So this is going to be decaying. So that means it needs to be a minus sign right there because it's not getting bigger, it's getting smaller. So then you're gonna type all of that into your calculator and you end up getting 50,280. And then how should you round this? Since you're talking about people, go whole numbers. So you just kind of have to read like to know what to round. If it's money, you're gonna go 2 decimal places. If it's people, obviously you're gonna do whole number. Sometimes the instructions might say nearest tenth, whatever. You just kind of have to read and know the situation. So it would be 50,281 people. Okay, last problem. Well, it's the same problem, but a couple different ways. A friend claims after he invests money inherited from his uncle, he will be a millionaire by the time he is 30. He says that if he puts $165,000 into an account that will earn 13% interest, if he is 16 years old right now, will he have $1 million by the time he is 30? So let's figure it out. So we've got our, let's talk about the P. The P is 165,000. Wish I had a rich uncle to give me that money. The rate would be 13%. So move your decimal over 2 times, that's 0.13. And then the time would be, if he's 16 years old now and he will be 30, you would do 30 minus 16 and get 14. So 14 years. And then on this one, it doesn't say anything about compounded continuously or quarterly or anything like that, so your n is 1 again. All right, so I'm gonna set up the problem. So I have 165,000 parentheses. This is getting bigger, so we're going to add it. I'm gonna skip the rate divided by the n. It's just gonna be 0.13 to the 14th power. All right, so stick that in your calculator. And you get $913,234.17. All right, so he did not quite get to $1 million, but he got pretty darn close. So now, what would happen if the same thing, if we did the same thing, except this time it was compounded quarterly? So all of that is going to stay the same except for the n. What does quarterly mean? Well, that's 4 times. So it would be compounded when the n is 4. So now we're gonna have almost the same formula except a couple things are gonna change. So it'll be 1 plus 0.13 over 4. And then to the formula is n times t, so 4 times 14. All right, so stick that in your calculator, and remember whenever you do the exponents, you're probably going to have parentheses around that number. All right, so he got even closer. So 989,298.44, almost a millionaire. So now what if it's compounded monthly? So again, it's the same thing except the n is going to change one more time. What does it mean to be compounded monthly? That means it's going to be compounded 12 times within each year. So your n changes to 12. So same thing, so 165,000 parentheses 1 plus 0.13 divided by 12 to the 12 times 14. Okay, stick that in your calculator. I think he makes it, yes, he does. So now he has $1,008,437.89. Okay, now last problem. What if he compounded it continuously? So this is that PERT formula. So the P is still going to be 165,000. The rate is still 13% or 0.13. And the time is still 14 years. Okay, so I would highly suggest you putting this in your own calculator. So we're going to have 165,000 times E, and there is a button on your calculator, look for it. It's like E to the, and now you have an exponent, 0.13 times 14. And again, you're probably going to have parentheses around that. So I highly suggest sticking this one in your calculator just so you know where the button is, because you will need it later. So let me do that. Oh, I forgot the parentheses. It's already messing up. All right, and so you get $1,018,356.64. So even more whenever it's compounded continuously. All right, that is it on this lesson. Thanks for watching and have a great rest of your day.